All right, so I'm going to be going over the Rolle's theorem. I don't know if it's called the Rolle's theorem. I just said the Rolle's theorem. I'm going to go over Rolle's theorem first, and then the next part, I'm going to go over the mean value theorem. Right, so the Rolle's theorem, what it says is that if f is a continuous function on a closed interval ab, and it's differentiable on the open interval ab, and if f of a equals f of b, then there is at least one number c in ab such that f prime of c equals 0. All right. So what does that even mean? Like what? What is that? Well, it's actually quite simple. So let me just draw a picture to show what's going on. So draw a little x, y axes, x, y. Now let's look at the conditions. So we're saying that the function has to be continuous. Okay, so we're going to draw a function with no gaps. And it's going to be differentiable, so we make it smooth. And it's f of a equals f of b. So this is saying that the endpoints or the y values at the end of the interval are equal. So if I make, let's say this is a, and this is b, and I'm going to say like, okay, let's say this is d. That means that both the endpoints of the function are the same. That's it. So in other words, we're saying that's a f of a, and that's going to be b f of b. But they all lie on the same line. That's equal to where that's d. They all line on line y equals d. So they both have the same y value, in other words. And this is the function. So if I draw a function with the same endpoints, it's saying that I have to find a point between a and b where there's going to be a horizontal tangent line, because that's what f prime of x, or f prime of that number being 0 is. That's what f prime being equal to 0 means. So let me draw this function that does this. Let's say I do this. So again, I just made some random function, made sure to went through those endpoints. And you would probably guess right about here, up here at this point, the tangent line would be 0. We would have f prime, whatever this point is, I'm going to call that c, is equal to 0. And what do you know? C is between A and B. Like magic. It's all this thing is saying. It's all this thing is saying. It's pretty amazing actually when you think about it. It doesn't have to, and the function doesn't have to be just going up like that. If I do a function again with the same endpoints, maybe I do a function that goes downward, but it comes back up. There's another function, but then see, I would still have a horizontal tangent line here. I can call that maybe like C1 or something. I'll call it C1. So at this point here, still between A and B, the horizontal tangent line is equal to 0. Or there's a horizontal tangent line on the function, as long as the endpoints are equal y value. So that's all Rolle's theorem is saying. Now applying this in problems is actually where students get confused. So let's go work out. Let's go work out some practice problems, because that's the best way to learn math, right? So here we're gonna illustrate Rolle's theorem. We're gonna find the two x-intercepts of this function that's equal to x squared minus 3x plus 2, and show that f prime of x equals 0 at some point between the two x-intercepts. I think this got typed off. I printed it. Some x, we'll say at some x value between the two x-intercepts. Okay, so what does this mean? Well, let's first find the two x-intercepts. Remember with the two x-intercepts, how you find that? That's essentially when the y value is equal to 0. It's where they intersect the x-axis. So we're gonna, when y is 0, in other words, we solve for the zeros of this. So we make zeros equal to that function, or we make it equal to that. This is going back to your algebra days. See, all that factoring is coming into good use now. What we do is we factor this into x minus 2 times x minus 1. And we get that one of our intercepts is going to be at 2, and the other one will be at 1. We have two x-intercepts at 1 and 2. So I'm going to draw a picture with this because it's going to be really helpful to understand this better. So what's going on right now? We have two x-intercepts at 1 and 2. So 1, 0, 2, 0. So what is it saying? Like, we're using Rolle's theorem. It's just find f prime of x find the derivative being equal to 0 for some x value between two x-intercepts. Well, the two x-intercepts, remember, think of this as your A. This is your left bound, and think of this as your right bound. That's your B. That's where you're bounded. So you got to find the x value in here. Find the x value in here with the same y value equal to 0. Remember, all along this line, y equals 0. So, well, not the same y. Well, since these two values have the same y value of 0, that's what Rolle's theorem is saying, that the endpoints are the same. So both of these values have the endpoints with the same y values. So there has to be a point on the function with a horizontal tangent line between a and b. So let's find first the equation of the derivative. So that using the power rule, f prime of x will be equal to 2x minus 3. And we want to find where the derivative is equal to 0. So we solve for the 0 of this. 0 is equal to 2x minus 3. And we're going to find that our x value will be 3/2, or 1.5. So we're saying when x is 1.5 on the function, there's a horizontal tangent line. Horizontal tangent line at the point where x is 1.5, which is right in the middle here. So our c value is this, or our c value is 1.5. So again, another way of writing c, 1.5. Now, now to build off of this, it's like, well, what does that mean exactly? Now I can't see the function. That's why let's graph this function. This is actually, your regular parabola. This is actually not too hard to graph, because this is just going to have a vertex in the middle. If you remember, the vertex is always in the middle of the two x-intercepts. The middle of the two x-intercepts happens to be 1.5. So let's just find the y value here, like evaluating f of 1.5. I'm going to get 2.25 minus 4.5 plus 2. It becomes negative 0.25. So the vertex is actually at, put a little downer, lower negative, easier to see. The vertex is at 1.5 comma negative 0.25. And that makes sense because your parabola would be doing this whole thing. Oh, I kind of messed up there. That's what your function is. And that, what do you know? Of course that makes sense, because that means at the point here, f prime of c, or in this case, f prime of 1.5 is equal to 0, because that's where the vertexes are in the minimum, and there's a horizontal tangent line at the minimum, because that's just the vertex of this parabola. So there you go. So it's very good to always have a visual and draw a graph and make sense of it, because you don't want to just do these by doing steps and calculating, not really know what's going on, because it's going to make this really confusing. So let's do another one. So here we got let f of x equal to x to the fourth minus 2x squared plus, oh no, just this minus 2x squared. Find all the values of c in the interval -2, 2 such that f prime of c is equal to 0. All right, so we don't know what the y values here are, but to make sure it's that it satisfies Rolle's theorem, that means that f prime of -2 and f of 2 and f of -2 both have to equal the same thing for it to work. And that would be, let's see, 2 -2, 4, 16 minus 2, 4, 8. That would be 8. They're both going to be 8. Yeah, so they both have, so this graph has points of -2, 8 and a 2, 8. Okay, so I'm gonna just draw the graph here, because again, this is really gonna help you with these problems. I really advise it, even if the problem isn't asked for, and even your teacher doesn't make you because when you're learning this and studying it on the AP exam, you have to understand it. So let's go -2/8. I'm trying to do my best. Let me see, it's over here. -2/8. 2/8, let's say it's over there. Guess that'll be 2. Not perfect, but that'll do for now. Yes. Doing this boundaries kind of, just give you a hint of what's going to happen here, or what we're going to see here. Okay, so we know these 2 points are in the function. So we know Rolle's theorem is satisfied because this is going to be differentiable and continuous. It's a polynomial. Now, let's find the equation for the derivative, so then we can find the value of c that will make the derivative equal to 0. So f prime of x will be equal to 4x cubed minus 4x. We need to make f prime of x equal to 0. So we're going to make 0 equal to 4x cubed minus 4x. Solve this for the zeros and factor out a 4x times the x squared minus the 1. And then this happens to be 0 equals 4x times x minus 1 times x plus 1. My zeros are going to be 0, 1, and the other one is going to be -1. So 3 values of x that will be equal, that where the derivative will be equal to 0. And let's see, which of these are between -2 and 2, and they all are between -2 and 2. So this graph actually is going to have 3 horizontal tangent lines. So again, I'm going to draw the graph so you can see exactly what's going on. If you evaluate this function, let's plug. If we plug in 0, that's easy. We know the function is going to be go through 0, 0. If you plug in 1, you're going to get 1 minus 2, you're going to get -1. So 1, -1. And same thing, you plug in -1. -1, -1. The function actually does this sort of thing. I try to draw it as best as I can. It's supposed to be like this, symmetrical. It's kind of like what a monster looking thing. I'm very good. I messed up there, but hopefully you get the picture. It's kind of like a butterfly looking thing. But the point is for you to realize, see at these points, we have horizontal tangent lines. All at these points, f prime of, x is equal to 0 at these 3 points. That's what's coming on here. We're getting the values of x on the function where you get horizontal tangent lines. And that's what Rolle's theorem is saying. It's actually a big deal when we go on later in the course, because it connects significantly to the next theorem, which is the mean value theorem, and eventually the fundamental theorem of calculus. So make sure you practice this and understand it.